Hello everyone, welcome to my channel CISE Topper Classes. Today we are going to discuss M.L.aggarwal Class 9 Mathematics, Chapter 16 Mensuration, Exercise 16.2, question number 1 to 10 of M.L.aggarwal Mathematics. So let us start solving this exercise here in this video.
Now let us solve here exercise 16.2. So firstly we will know the formulas which we are going to use in this exercise. So first formula is for perimeter of quadrilateral. Here perimeter is the sum of all the sides and quadrilateral has four sides. Let them be A, B, C, D. So this will be A plus B plus C plus D. Now the second thing is area of quadrilateral here. So, in the first case is given that when one diagonal and the perpendicular from the remaining vertices of the quadrilateral is given to us to this diagonal, then the formula for area is half into one diagonal into sum of lengths of perpendicular drawn it from the remaining two vertices. So, you can see on the book also the diagram is given and from that you can conclude that. The second part is when diagonals of a quadrilateral intersect at right angles. Means if they intersect at right angles, then the area of quadrilateral ABCD is area of triangle ABC plus area of triangle ACD. So here it will be half of AC into OB plus half of AC into OD. This will be half AC OB plus AD equal to half OB plus OD is BD, so we can write half AC into BD. Now, area of quadrilateral here, ABCD will be the product of diagonals, half of product of diagonals. So, here some special types of quadrilaterals are given. So, firstly, let us see the rectangle. Area is length into breadth. Perimeter is 2 into length plus breadth. Now, the second is square. Area is AB square, means the side A square. Perimeter is 4A. Now, the diagonal length D is under root A square plus A square. By the Pythagoras theorem we can apply as, let this be the square here and this be the diagonal D. So because this is perpendicular in a square, means it is a right angle triangle. From that we can conclude this part. Now we have a parallelogram. Here area of a parallelogram is base into height. Rhombus area we know only product of diagonals, half into product of diagonals. Now the area of trapezium here is area of triangle ABC plus area of triangle ACD. We can conclude and from that we can write half of sum of parallel sides in a trapezium into its height. So this is the formula for area of trapezium, and these are the all the formulas which we have to learn by heart to solve this exercise 16.2. Let us solve here exercise 16.2 first question. The first part is we have to find the area of quadrilateral whose one diagonal is 20-meter long and the perpendicular to this diagonal from other vertices are of length 9 centimeter and 15 centimeter. We know the formula of area of quadrilateral if the diagonal is given and the perpendicular to the diagonal are given. So from that area of quadrilateral, let this quadrilateral be ABCD, so we can write it as 1 by 2 into one diagonal here, one diagonal into the sum of length of perpendicular. So we can just write here as 1 by 2. Here diagonal is given as 20 centimeter long. This is given 20 centimeter. So we can write 20 centimeter into sum of diagonals will be 9 plus 15. So this will be 24. We will cancel out this part. So it is 240 centimeter square. So this is the final answer here in this question. So area is given that 240 centimeter square. Now let us solve here first second part. We have to find the area of quadrilateral whose diagonal are of length 18 centimeter and 12 centimeter and they intersect each other at right angles. We know in the case of right angles, if the diagonals intersect at right angles, we have the case as area of quadrilateral will be half into product of diagonals. So we'll apply the formula here. Let the quadrilateral be ABCD. So area of quadrilateral ABCD we can write quadrilateral ABCD is equal to 1 by 2 into product of diagonals. So this is the product of diagonals here. Here we can write in the place of diagonals as 18 centimeter into 12 centimeter. So this will be 6 and 18 into 6 will be 108 centimeter square. So this is the area in this, and this is the solution of the first second question. Let us solve here. Second question, find the area of the quadrilateral field ABCD here, whose side AB is 40 meter, BC is equal to 28 meter, CD is 15 and AD is equal to 9 meter. We have to find the area of this. So to find this area, we can write as the sum of these both triangles. Means the area of quadrilateral ABCD is area of triangle BCD and area of triangle BAD. So let us write firstly area of quadrilateral is equal to area of triangle BCD plus area of triangle BAD. To find the area of BCD here, we will use the Heron's formula by finding the hypotenuse in this Pythagoras theorem, because angle A is equal to 90 degree, and here the area of triangle BAD will be half base into height. So firstly write the area of triangle BAD here. So this is equal to half into base into height. Base is 40 and height is 9. So just cancel out this. Here it will be, so here on cancelling this will be 180 centimeter square. So this is the area of triangle BAD here. Now to find the area of triangle here BCD, we can write the area of triangle BCD as equal to, by Heron's formula we have to find, means this will be under root semi-perimeter S minus first side, S minus second side and S minus third side. Firstly we'll find the semi-perimeter. So here by Pythagoras theorem BD square is equal to BA square plus 9 sorry AD square. So we'll put the value, this will be 40 ka whole square plus 9 ka whole square means 1600 plus 81 equal to 1681, means BD is equal to 41 meter. I'll put the value in this. So firstly semi-perimeter will be A plus B plus C divided by 2. So this will be 40 plus 9 plus 41 divided by 2, means 90 divided by 2. We can write this. Sorry, this is not 40, we have written wrongly. It is 28 plus 15 plus 41 divided by 2. Here we can write the sum as 9 plus 5, 4, 3, 4, 84 divided by 2, means 42 meter is the semi-perimeter. We'll put the value in the Heron's formula. So this will be 42. 42 minus 41, 42 minus 28 and 42 minus 15. So this will be under root 42 into 1 into 4 here, 14 into 42 minus 15 will be 7 and this will be 27. We'll multiply this part. So this will be under root 15,876. We will take the under root. There will be 126 meter square. Now we will, sorry, this is here also it is meter square. We will add these both area of triangle. So area of quadrilateral, from there we can conclude area of quadrilateral ABCD is the sum of these two. So 126 plus 180 will be 6 here, and 12 plus 18 will be 30. So 306 meter square is the final answer here in this question. And this is the solution of the second question here. Let us solve your third question. We have to find the area of quadrilateral ABCD in which angle BCA is equal to 90 degree, AB is 13 centimeter and ACD is an equilateral triangle of side 12 centimeter. So here we can write the area of quadrilateral as the sum of these two triangles. So here area of quadrilateral ABCD is equal to area of triangle ABC plus area of triangle ACD. So this is half base into height plus under root 3 by 4. into side का whole square. We can write half as base into height of this triangle. So for finding this, we can write simply as the AC as the base and height as BC plus 3 under root 3 by 4 into 12 ka whole square. So for finding the value of BC, we can use Pythagoras theorem here in this right angle triangle. So by Pythagoras theorem, we can write it as 13 का whole square equal to 12 का whole square plus BC square. So this will be 169 minus 144 equal to BC का whole square. 25 equal to BC का whole square. We can take the under root. BC is equal to 5 centimeter from that. Now I'll put the value of BC. So this will be half AB as 13 and BC as 5. So sorry, this is AC. So AC as 5 and here this is BC we have find it means it is 5 and AC we have to write. This is 12 plus 3 under root 4 into 12 ka whole square. We'll cancel out this part. So this will be 30 plus 4 under root 3 by 4 into 12 into 12. This will be cancelled out by 3 and this will be 30 plus 36 under root 3. So here we can write as term as 30 plus 36. We'll put the value of under root 3. So this will be 1.732. And the final answer will be on adding 30, on multiplying this, we'll get 62.28. And this will be 92.28 centimeters square as the answer of this question. This is the area of quadrilateral. Area of quadrilateral ABCD will be 92.28 centimeters square as the final answer. And this is the solution of the third question. Let us solve here fourth question. We have to find the area of quadrilateral ABCD in which angle B is 90 degree. AB is equal to 6 centimeter, BC is 8 centimeter and CD is equal to AD means 13 centimeter. So here we can write this part as area of quadrilateral ABCD will be the sum of these two triangles ABC and ADC. So firstly write it as area of quadrilateral ABCD is equal to area of quadrilateral triangle here ABC plus area of triangle ADC. So here we can write the area of triangle ABC as half base into height. So area of triangle ABC is equal to 1 by 2 into 6 into 8. This will be 4 and this will be 24 centimeter square. Now we have area of triangle ADC we have to find. For finding this, firstly we will find by Pythagoras theorem. By applying Pythagoras theorem, we'll find the value of AC. So this will be AC square equal to AB square plus BC square. Put the value 6 square plus 8 ka whole square. So here we can write this as 36 plus 64 equal to 100 means AC is equal to 10 centimeter. So this is here 10 centimeter. Now we have to find the area of this. So for finding, we will find the semi-perimeter by Heron's formula here we will find. So for finding this part, firstly we will find the semi-perimeter. Semi-perimeter is A plus B plus C divided by 2. So 10 plus 13 plus 13 divided by 2 will be 6. 46 divided by, or we can write 36. Sorry, 36 divided by 2. This will be cancelled out and 18 centimeter. I'll put the value in the formula. So it will be 18. 18 minus 13. Again 18 minus 13. Then we can write here as 18 minus 10. So this is equal to under root 18 into um, 5, and this will be also 5, and here 8. So we can write this part as 9 into 2 into 5 into 5 into 4 into 2. So it will be 3 into 2 into 2, and because 4 is 2 into 2 and into 5, so this will be 6 into 10, means 60 centimeter square is the area of triangle ADC. This is 60 centimeter a square. Now we will add these two area of triangle ABC. Here this is 24 centimeter square, and area of triangle ADC. So here we can write area of quadrilateral ABCD equal to the sum. So this will be 24 plus 60, means 84 centimeter square is the final area of this question. So this is the solution of the fourth question. Let us solve here fifth question. The perimeter of a rectangular cardboard is 96 centimeter. If its breadth is 18 centimeter, we have to find the length and the area of the cardboard. So here we have breadth is given, we have to find the length. So the formula for the perimeter of a rectangle is 2 length plus breadth is equal to the perimeter. So we will put the value of breadth and perimeter here to find the value of length. So this will be 2L plus 18 equal to perimeter is 96 centimeter. Means length plus 18 is equal to 48, and length will be 48 minus 18. So this will be 30 centimeter. So length is equal to 30 centimeter here, and we have to find the length and the area of the cardboard. So area will be length into breadth. So we will write the value of length which we have find it. This will be 30 into 18. So on multiplying this, the final answer will be 540 centimeter square. So this is the area here, and this is the answer of this question. Let us solve here sixth question. The length of the rectangular hall is 5 meter, means 5 meter more than the breadth. Let the breadth be here b, and the length be b plus 5, because it is 5 more than breadth, and the area is given to us as 594 meter square. We will put the value in area as length into breadth is equal to the area in a rectangle, means length is b plus 5 and breadth is b equal to 594, means b square plus 5b minus 594 equal to 0. From that we can find the value of breadth here. So here this will be, on factorizing it, we will get as 27b minus 22b minus 594. So this we can take b as common here. So b plus 27. Here we can take common, and here we can take common as 22. So minus 22 will be b plus 27. So here b is equal to 22, or b is equal to minus 27. B is equal to minus 27 is not possible, because in minus we can't take the breadth here. So the final is b is equal to 22. So b is equal to 22 meter here. And now we have to find the perimeter. The formula for perimeter is 2 length plus breadth. So here we will put the value in breadth as length is equal to b plus 5, means it will be 22 plus 5. This is 27. So the from that we can conclude the length and breadth is 27 and 22. We'll put the value for finding the perimeter of this rectangle here. So it will be 222 plus 27, means uh, 49 into 2. So this will be 98 meter. This is the final answer in this question here, means the perimeter of this rectangle is 98 meter. Let us solve here seventh first part. The diagram given below shows two paths drawn inside a rectangular field 50 meter long and 35 meter wide. The width of each path is 5 meters. We have to find the area of the shaded portion here. So here we have to find the area of this Let this be A, B, C, D here, and this be P, Q, R, S. So these both, the sum of these both we have to find. So here we can write the area of this area of shaded portion as the sum of area of A, B, C, D plus area of P, Q, R, S minus area of, here this is L, M, let this be L, M, N, O. So minus area of L, M, N, O. Because on adding both these areas, we will get two rectangles of L, M, N, O. So here we can write this part as one rectangle we will subtract and we will get the area of this shaded portion. So this we can write because area of ABCD is length into breadth. Here the length is 50 meter and the breadth is given as the of this path as 5 meter. So we can just multiply this in the first part as 50 into 5 plus here the length of this path is 35 meter and the breadth is 5 meter again. So this will be 35 into 5 and the length and breadth of the rectangle LMNO is 5 into 5. So this will be 5 into 5 the area and we can write it as 250 plus 175 minus 25. So we can write this. So here it will be 250 plus 150 on subtracting 175 by 25 and the answer will be 400 meters square. Means this is the answer here in this question, seventh first part. Now let us solve here seventh second part. In the diagram given below, we have to calculate the area of the shaded portion and here all measurements are in centimeters. So we can write area of shaded portion. Area of shaded portion as area of rectangle ABCD here. Let this be ABCD minus area of these five triangles, five squares, sorry. So here we can write it as area of rectangle ABCD will be length into breadth 8 into 6 means 48 and area of 5 squares will be 5 into area of these squares means side ka whole square is the area of the square, so 2 into 2. We can write it as 48 minus 20. 48 minus 20 will be 28 centimeters square. So this is the final answer in this question, means the area of shaded portion here is 28 centimeters square and this is the solution of 7th second part. Now let us solve here 8th question. A rectangular plot 20 meter long and 14 meter wide is to be covered with grass leaving 2 meter all around. Find the area to be laid with grass. So here we can simply write, we have to find the area of the grassy lawn. Means the length of the grassy lawn we can write as, because here also 2 will be subtracted and here also 2 will be subtracted from this side in the length. So it will be 20 minus 4 means 16 meter of the grassy lawn, length of grassy lawn here. Now we have to find the breadth. Again in the breadth we will subtract 2 and 2 from the 2 from this side and 2 from this side. So breadth of the grassy lawn is equal to 14 minus 4. So this is also 10 meter. So here we can write the area of this grassy lawn. The length into breadth will be written here. Length is 16 meter and the breadth is 10 meter. So we can write 160 meter square as the final answer here in this question. So the area of the grassy lawn is 160 meters square and this is the solution of the 8th question here. Let us solve here ninth question. The shaded region of the given diagram represents the lawn in front of a house. On three sides of the lawn there are flower beds of width 2 meters. We have to find the length and the breadth of the lawn. So here we can see that the first part is, this is the lawn here. So here the width of this flower bed is meters. So we can write here that if we subtract here 4, 2 meter from here and 2 meter from here from the length, we will get the length of the lawn. So length of the lawn is equal to 30 minus 4 means 26 meter. Now we have to write the breadth of the lawn. Again breadth of the lawn, because from one side only it is covered, flower bed is covered as three sides. So here one side only we will subtract, means breadth of the lawn will be 12 minus 2. So this will be 10 meter. Now, the second part of this question, ninth question, is here we have to write hence or otherwise find the area of the flower beds. So we have to find the area of flower beds. So area of flower beds will be, if we subtract the area of this, let this rectangle here be ABCD with the area of the lawn. So area of flower bed is equal to area of rectangle ABCD minus area of lawn. So here, because length and breadth we have find it previously in this question here of this lawn. So we can write area of rectangle as 30 into 12 minus 26 into 10. So here we can write this part as 360 minus 260 means 100 meters square. Area of flower bed will be 100 meters square. So this is the final answer of this question here. Means here it is 100 meters square. So this is the answer of the second part, and this is the answer here of the first part. And this is the solution of ninth question. Let us solve a 10th question. A footpath of uniform width runs all around the inside of a rectangular field 50-meter long and 38-meter wide. If the area of the path here, this footpath, let this be footpath here, and we have to find find its width. Means the width of the footpath we have to find. So let this width be x centimeter, and here we can write, here we can let it as x meter, because all are in meter only. So for finding the area of this rectangle ABCD which is given, so we can just multiply the length and breadth, and here let this be ABCD here, means this will be 50 into 38. So here we can write this as 1900, means 1900 meters square is the area of this rectangular field here. Now, to find the area of this, the left out part from the footpath, we can just write the length firstly, because we have let the width as x, so we can write it as 50 minus 2x, and breadth of the remaining part as 38 minus 2x. Means if we will write the difference between the area of rectangle and the remaining part area, we can write the area of the footpath. So here we can write area of footpath equal to area of rectangular field ABCD minus area of rectangular field PQRS. So you can just write the value of area. This is 1900. We can multiply this. So this will be 50 minus 2x into 38 minus 2x. So this is equal to 492 here. We can write it as 900 minus, again on multiplying this we will get 1900 minus 100x minus 76x plus 4x square. So on opening the bracket here we will just differentiate it and just calculate this value. So it will be, from here we can just write, this will be cancel out and it will be 492 plus here this will be on opening the bracket plus here. So plus 100 plus 176 is equal to 176 minus 4x square, means if we take common here as 4, so this will be 44x minus x square and it will be 492. We will cancel out this part. On cancelling, we will get 123, means x square minus 44x is equal to 123. So we can just calculate the value here. X square minus 44x minus 123. So we can write this part as plus 123 only. We will factorize it and it will be x minus, because 123 we can write it as 41 into 3. So we will write, firstly we will write it in a simplified version. So x square minus 41x minus 3x, on adding this we'll get 44x, and in multiplying we will get 123. So from that we can get factorization. X as common, x minus 41 minus 3 as common, x minus 41, means x is equal to 41 and x is equal to 3. So this is the width here, and this is not possible. 41 is not possible because this is not in the limit of the width only. So we can write the width as 3 meter. So this is the final answer here in this question. Means the width of the footpath here in this x is 3 meter. 41 is not possible because. So this is the final solution of the 10th question here.
Thank you for watching my video. If you like this video, please like, share and subscribe my channel.